Hi everybody, we're going to talk about even and odd functions today. Just to start us off, a function is even if when I put in negative x into my function, it in fact returns the original function. Okay? And a function is odd if when I put in negative x, it returns the opposite of the function that I had put in. So those are your two rules. That's the algebraic way of being able to tell if a function is even or not. We'll talk in class about the graphical way of looking at even and odd functions, but algebraically, your test is to put negative x into your function. If it returns the exact value that you had before, then it's even. If it returned the opposite value of what you had before, it is odd. If you want to talk about just some examples. A function is even, let's just say if I put 2 into my function, and I also then put negative 2 into my function. If those two y values were in fact identical, then we can say that the function is even. Okay? But let's just say I put negative 2 into my function, and it actually returned the opposite, or the negative value of what I'd get if I had put 2 into my function. Okay? So if that was the case, then it would end up being odd. So the algebraic way of finding even and odd is to put negative x into your function. So let's go through and do some different examples. I want you to tell me if these following functions are either even, odd, or neither. And we're going to do this algebraically. So in order to tell algebraically if you have an even or odd function, we want to put negative x in for all of my x's. So let's find f of negative x. Okay, so wherever I see an x in my function, I'm going to just insert a negative x. So I have 3 times negative x to the 4th minus 8 times negative x squared plus 4. And I'm just going to simplify this out and see what happens. Well, I know that negative x to the 4th power is a positive x to the 4th. So this piece right here would end up being positive 3x to the 4th. The negative in there raised to the even power is still going to end up making it positive. Then this guy right here, negative x raised to the 2nd power, is also going to be positive x squared. So that in turn is not going to change the sign of the negative 8. So this is still also going to be minus 8x squared. And then 4 didn't have anything put into it, so it still remains as a plus 4. Okay? If I look at this function that I got after I put all my negative x's in and I cleaned it up, if he was in fact identical to my original function, then we could say that f of negative x is the same as f of x. And if that's the case, then we can assume that our function is in fact even. Okay? Let's take a look at another example. All right. We have now g of x here, and we're going to tell if it's even, odd, or neither. So your test, remember, is to put in negative x in for all of your x's. So when I put negative x in, I will have 4 times negative x raised to the 7th power plus 2 times negative x raised to the 3rd power minus, and then there, that x will also get a negative x plugged into him. Okay? Let me erase this little piece there. All right, so let's clean this up now. A negative x raised to the 7th power is going to return a negative x to the 7th. So I can go ahead and move that negative to the front and say that that would be negative 4x to the 7th power. It's just going to change the sign of that term. My negative x raised to the 3rd power is also going to change the sign, so that would be a minus 2x to the 3rd. And then this negative x multiply, or this a minus a negative x is going to change the sign there, so that will be plus x. If I could, I want to see, well, right here, is this guy exactly the same as him? No, he's not. So we want to see if he is in fact odd, because we know he's not even, or he'd be identical. Well, if he's odd, what we can do is we can GCF out a negative 1. If I take a -1 out of everything, that's going to simply just change the sign of all of my terms. So that would be a positive 4x to the 7th plus a 2x to the 3rd, minus an x. If after I GCF'd out that -1 and the inside that I have is now identical to my original function, then we can say that f of -x is simply the opposite of my original, right? I'm just taking -1 times my original. If that is the case, then we can say, yes, he is odd. Okay? Final example. We have h of x equals x to the 5th plus 4x to the 3rd minus 10. Okay? So we want to tell if this function is even, odd, or neither. So here we go. H of -x, remember that's our test. We're going to put -x in for all of our x's. So that would be -x to the 5th power plus 4 times -x to the 3rd power minus 10. Okay, and we're going to clean that up. So we have here, this would change the sign of that. So that would be -x to the 5th power. This -x to the 3rd would change the sign of that term. So that would be minus 4x to the 3rd power. And then that minus 10 has nothing there to change the sign. So he remains as a minus 10. If I look at this, I can tell he is not identical to my original. So he's not even. I can also try to tell if he's odd by GCFing out a -1. So that would give me a positive x to the 5th plus a 4x to the 3rd plus a 10. And again, we look at our inside piece. And if our inside piece is identical to our original, then he is odd. Oh, look, this negative did not change down here. So he's not odd. Since he's not odd, then we cannot say that f of -x equals f of x, or f of -x equals -x, negative f of x. So in this case, he is neither. What you'll start to see here, folks, is that the powers that are on each of these terms will give you a big clue as to whether it's even, odd, or neither. You just really do have to be careful with the constants that are attached onto the end, because at first glance, a lot of kids want to look at this and say, oh, he's odd, because all of my powers are odd. But this constant on the back side negates that thought. Hope this makes sense, and we'll see you in class. Bye, everybody.